Hey, this is Steven from LegitTechTutorials, and welcome back to our product design series. We are continuing our design on the shredder. Just a quick update. I called the supplier, Sims Mill Management on Monterey. One of my buddies works over there, and I asked him what type of steel he carries. He carries ASTM A36. Which unfortunately is a pretty low grade of steel. It's comparable to 1018 steel. I mean, not necessarily low grade. I mean, it's good steel, but it's low carbon, difficult to harden, difficult to heat treat because of its low carbon content. I mean, you could look here, and I think the one I was looking at, the 4142 or whatever, was like 207 megapascals young modulus. So 207 gigapascals, I think. 390, Yes, 207 gigapascals is the 4142, and this one's 200 megapascals. 200 gigapascals. So 7 gigapascals higher than the other one, and also 4142 has quite a bit more carbon content, so it's easier to harden. Or you could even buy them pre-treated, and but there it's harder to file an edge into it before you throw it in, and it is harder to file a cutting edge. So what this means is I might have some difficulty heat treating it. What I might have to do is I might have to diffuse carbon into it for an extended period of time, where it diffuses carbon all the way through to the bottom, which is, takes a very long time and a lot of energy and a lot of CO2. So, which is carbonization of steel. So I might just try to heat treat it, even though generally speaking it doesn't heat treat that well because of the low carbon content. So I might have to see, but the upside is that it's very cheap, compared to the 4142. The other one I was looking at, 4142 pre-treated or even normalized, is very, very expensive. So yeah, ASTM A36, which is comparable to AISI 1018. Alright, so with that, we're back to our assembly. I still haven't really Googled anything about, copying whole assemblies or anything like that. But another thing that I could do is I could put this guy on an assembly and then just double drop the assembly in there. That might be a good idea. So I'll have like this assembly. That's actually a very good idea. Maybe I should do that. So yeah, what we'll do is we'll make sub-assemblies. So let me see if I could copy and paste this guy. Let's do another sub-assembly. So let's call this shredder assembly. So this is the shredder shaft assembly. Shaft with an H. Assembly. Let me see, I don't know if I could copy across files. I'll find out right now. It doesn't look like it. But I don't want to keep doing this over and over again, so I mean, after I do this, I could just do it again. So I could just highlight the whole thing and copy it. So I mean, it's pretty much the same amount of time. Maybe I'll spend some time later doing this on this other file, but right now, for all purposes, pretty much just do this. Alright, so let's go ahead. Maybe close that. Oops. See if we can do this a little faster. it to be a slider, x-axis, then go front, zoom in, so the next one should be 2-inch, and then what I need to do is this guy here, I need to do 2-inch, so flop over here, flop to the front, whatever. Okay, so we're looking good so far. Alright, so what I'm going to do is select this. Let's go ahead and copy that. Paste. And move this over. Say OK. Look at this spacer. Right click move. Go over here. And I'm going to capture position. And I'm going to assemble. Oh, okay, I think I still got it. Assemble here. That looks okay. So yeah, hopefully when you guys are doing this, you look at the you look at some way to copy all the joints and stuff. Even though you'd have to go in, theoretically speaking, you would have to go in and change all those numbers anyways, because I'm going to assume that it's going to just do all the numbers over again. Yeah, and I probably shouldn't even be doing a slider. I might have to go back and change all those to rigid. So yeah, maybe while I'm doing this, I'll talk about a few other things. Oops, capture position, almost forgot. So yeah, we have 836. It's going to be very good for the price. It's going to be very good steel for the price. So I'm pretty excited about that. And so yeah, I'm probably going to have to. Okay, so I was thinking about either building or buying a furnace or a kiln or whatever you want to call it. I don't know what technically technically makes each different between a kiln as far as the definitions and stuff, as far in between a kiln and a furnace. So okay, so I was looking at some kilns or furnaces from Even Heat, and they have a few that are 1500 watt heaters that are like they're pretty good price. They're about $1,000 or so, and they all use, of course, IFB or insulated fire bricks. Insulation fire bricks. So those insulation fire bricks run about $4 a piece. $4 a piece, depending where you get a Morgan or some other thermal ceramics place. So what I was thinking was maybe building my own. So I priced out So yeah, 1500 watt heater, and the 1500 watts will heat up this small area. I think it was like a 6x9 by 13, somewhere around there, 6x9 by 13. It'll heat that area up to about 2,000 degrees Fahrenheit. So that's enough to pretty much heat treat almost anything that I would, want to heat treat, or even carburize anything that I would want to carburize. So, but you could get that same result if you use your own, if you create your own. So like I said, they're about $4 a piece or something like that for I think it's 4 inches wide by 9 inches long by 2.5 inches tall. And they're called K26. K26, sorry about that, I need to text somebody real quick. Okay. Yeah, so it was 4 inches wide by 9 inches long by 2.5 inches tall. So I did the math on it, and it was going to be like 20 bricks for something like what was it? It was like 6x6 by 10 or something like that. Pretty even bigger size than the than the even heat. Sorry, not ever heat, even heat. So that's pretty good. And the total price was about total price was about $120, $130. So that was to build the exterior, and then you had to build some sort of steel housing, because the bricks are ceramic, so they're pretty brittle. So you don't really want them hanging under their own weight, really. So, it's gonna have to change. Okay. So you don't really want them hanging under their own weight, because then they could sag and then stuff happens. So what you need to do is you need to build an enclosure around it. A steel, some steel angle irons. So you don't have to do crazy, what's the word I'm looking for? Some crazy strong steel around it, but just something to hold it together. And then you could put a door. Then you need to put a hinge in a door and stuff like that. And then you need something to control it. But luckily, I have a whole bunch of and think the 1500 watt is about what was it, 20 amps or so. So you want to be able to at least handle 20 amps. So what I was thinking of doing was I was thinking of using my for the multi-shooter, the Mega. So using the Mega with the 2.8 inch touchscreen, because I'll have a few left, so I'll have one to use on that, and then I could use my MOS operating system to control a lot of it. I just need to add some more PID stuff, and then I could also do a program in like what's the word, the schedules, like how long to have it in there, and then have a buzzer. So because I think on Even Heat they don't have anything where you could use to like track how long it's in there. So you have to have a clock that watches it in order to know when it's finished. So with the Arduino, the Arduino-based solution, you could have schedules on there, and then be able to figure out when, you know, when you could. Oh, uh-oh. So you could figure out. Oh, okay, I didn't copy and paste it correctly. So you can figure out, you know, when to take it out. So I could have built-in schedules for different amounts of time as far as heat treating, and count how long it takes to heat treat, and also guesstimate at what the steel temp is at a current time, etc., in order to have the best, you know, have it do math operations, have it to do arithmetic operations rather than just do PID operations. So that way I could have a lot more control over what happens, and also it doesn't cost me anything extra in electronics because I already have those electronics. So I have I'm going to have a whole bunch of Arduino Megas left over. I'm going to have a few screens left over. I'm going to have some SSR relays, but I'm probably going to have to get those other ones, the big SSR relays that the big SSR relays, so I could have it take that 20 amps of current and not, you know, melt. So altogether, I think the heating element was $10 or so on eBay. You get a 15 watt or even a 750 watt for something like that, and then for $10, I'm gonna say 1,700 watts, like $10, and then you get the bricks for $120. You get the SSR relay for $10-15. All the other stuff I have is already free because I already have it. And what else? Well, you need the mortar, the high temp mortar, which is it was like $20 or something. I didn't paste it. Nope. So I think altogether it'd probably be $200 project rather than $1,000 to buy one that you still have to have, that you can't really modify too much. But theirs is pretty good. So I'd probably design mine around theirs. And then pretty much copy it. But besides using a standard PID, off-the-shelf PID controller and an SSR relay, using the multi-shooter with PID settings on there, and then use that instead of the off-the-shelf PID controller. So that way, like I said, I could put schedules and stuff like that. But in order to do A36, I think it was like 1,500 degrees Fahrenheit or so that I need to hold for about an hour per inch of thickness, but it's only 1/4 inch plate. So yeah. So I think what I'm looking at would be perfect for that kind of thing. But what I'll do for that is also probably make a video for that, as far as I need to do some simulations in order to figure out what exactly the temperature is. So what I could do is I could create a new material on here and load in those settings for the K. Also, I forgot to mention what the K26 stands for. K26 means that the brick is heat resistant up to 2,600 degrees Fahrenheit. So if you have a K23, it's resistant to 2,300 Fahrenheit. And then, so what I could do is I go and take the thermal properties of watt per Kelvin or whatever the units are, and then plug that in as a material. Oopsies. And plug that in as a material. Oopsies. And design the put all the bricks and I don't know about the mortar. I might have to. I don't know if they'll have the thermal properties for the mortar, but I'll probably put gaps in there and then fill it with something, and then just to get an estimate, or I'll just have it completely solid, so that we could look at what the temperature will be if I provide 1700 watts in the center of the thing, and see what it tells me. See what it tells me that it will be able to put out, and what it will be able to hold. And so I'll put in how much thermal conductivity will adapt to the outside, and then I'll put in the outside temperature, which in the shop most of the time is like 70 degrees. 70 degrees usually. So put in 70 degrees, 70 degrees outside temperature, and then this is thermal conductivity of the bricks, and then this is the heat I apply inside. What will the temperature stay at inside? Type of thing. Too far. What? 0.5? Oh, it needs to go in further. Okay, I think we got a few more left. This thing is tripping me out, so I'm going to move it. But yeah, also I forgot to mention what today was. Today's 11/4, 11/4/2016. So again, we're trying to shoot for the 17th or earlier, but that's looking kind of bleak. But we were shooting for it, and I already got the prices on steel. I know that from my simulations that I'm going to need to heat treat it because it's just. Oh, what the hell? Oh, there it goes. I have to scroll now. This thing's gonna be huge. Okay. I think after this one right here, we're pretty much done. I wonder if I could group these or something. Okay, cool. Create group. So yeah, this is definitely gonna need some organizing when I finish with this guy. Okay, 1 inch. Alright, so that's 1 inch from the back side, so that's a 1/4 inch. So now this, so this spacer should be the last piece. And that should be correct because I started out with a cutter, so I should end with a spacer. So yeah, so those are the few things that I've been thinking about. Gonna need something to heat treat this to get that Young's modulus up to 250 or whatever. And then I'm probably also gonna need a Rockwell hardness tester. And with the Rockwell hardness tester, it'll allow me to check like how much I've increased the strength of the steel, because it's the Rockwell hardness is a general test of strength, without having to do like an impact tester like a Sharpie or anything like that. Alright, we are looking good. I'm gonna save it, so okay. So what I'll do, figure out where the start of the whole thing was. Oh no. What did I do? What did I do? I didn't do anything. Okay. Okay. Let's rename this to shaft 1. Drive shaft 1, or drive shaft. This is going to be the left. Drive shaft left. Alright, and then let me see if I can I like group these? Well, that's quite a bit. So let's see if I could if I could create a whole new one of these guys. I don't know how to add. Oh, I guess I could. Whatever. Okay, let's suppress that, and what I'll do is I'll just go ahead and copy this whole thing again. So I'll just copy, and then I'll paste it. Wait, did it work? Nope, it's still in there. Can I change this whole thing into a component? Please don't tell me I have to do it all over again. But it looks pretty good. So let's see if I could just take this guy. Oh, that ain't in the center. Is this in the backside? What the hell is going on? There it goes. Oh, check it out. Cool. And I wonder if I could right click and and then just do like replace with or something. So like right click after I hit OK, after I get this all the way back up to the top. Just say that, set that D at 0 degrees. I wonder if I could just right click and hit replace. Alright, well, looks good. That will pretty much be it for this video. It's been Steven from LegitTechTutorials. Thank you guys for watching this video. If you liked this video, please subscribe for more videos like it in this series and other series as well. I'll see you guys next video. Thanks for watching. Take it easy. Peace.